Hello and welcome to another Tycho video. In this presentation, I would like to go into some detail on the process that is involved in determining which light curve solution or which period solution is deemed to be the correct one, or the presumed correct solution. So as one example, if we have two different periods here, one of 2.26 hours and the other being a multiple of that, so 4.52, the question is which one should be considered the correct one. Now, if you're just getting started with photometry of asteroids, there are some keywords that you might be familiar with, and bimodal could be one of those keywords. And typically you might think that the solution that has a bimodal curve is what you want. However, after doing some reading through the latest issue of Minor Planet Bulletin, and I'm sure in other instances of this kind of material, there is some discussion here. It says that when a low light curve amplitude is involved, for example, when the amplitude is less than 0.2 magnitude, and especially when it is less than 0.1 magnitude, then it should not be assumed that the light curve will be bimodal. In other words, having two min, two max pairs per rotation. So what does it mean for the amplitude to be low or small? So a small amplitude, what does that mean? Well, a small amplitude means that there is very little variation in magnitude. In other words, that this would typically be associated with a spherical object. So for example, our object here, 65803, that I was showing a light curve plot right here, it has, for example, amplitude of 0.1, 0.11 perhaps, so that is less than 0.2, so we would consider that to be a small amplitude. And indeed, this does typically indicate a rather spherical object. In contrast, another asteroid, 771 Libera, has an amplitude of around 0.53, and as you can see here, it is not as spherical, so it is more elongated, and so it does have that higher amplitude. In other words, the magnitude has a larger variation. So going back to this paper here, or this issue of Minor Planet Bulletin, again, what they're getting at here is that when you have that smaller amplitude, when you have that smaller variation, then you cannot assume that the solution will be bimodal. Now, as you skim through this issue, or if you were to do so, that you can also notice several references to a concept whereby they will invoke a split halves plot. So for example, if we do a search on that, you can see several references to that. So for example, monomodal light curve results in a solution that matches previous values, and split halves plot does not support the bimodal solution. So what does that mean? Well, split halves, what they're doing is they're essentially taking the two halves of the phase curve and overlaying one on top of the other to determine if there exists symmetry. So if symmetry does exist, for example, here's one. They are showing a split halves plot. So if they are symmetric, then they can be overlaid on one on the other, and that would indicate that the bimodal solution is simply a repetition of the monomodal solution. And if it is a repetition, then we can say that the bimodal solution is not likely to be correct. In other words, as they say here, the so-called split halves plot shows that the two halves are symmetric, identical, which significantly reduces the likelihood of the longer period being the correct solution. So for our purposes here, I have added this kind of functionality into Tycho. So for example, if you were working with this kind of object and you wanted to know, should it be this longer period that has a clearly bimodal curve, or should it be the shorter period that is not bimodal? So if I take a look at the bimodal curve here and I do the split halves plot, I've actually added two different variations of this. One is split phase, the other is split halves. So if I look at split phase, just to show you what that looks like, that simply overlays that second half that you saw here onto the first half. And you can see that it overlays quite well. Now if I do that for the first period, the first candidate, where it is monomodal, you see that they do not line up one on top of the other. So again, the bimodal solution here, they line up quite well. And you can also see that with the other variation. If I do split halves, as they like to call it, then you have, again, a very good match. They are very much symmetrical, which ultimately means that the bimodal solution, it is a repetition of that shorter period, which in other words invalidates the bimodal solution. Now if we take a look at another object, again 771 Liberia, where the bimodal solution is in fact the favored solution, we can do the same exercise. So if I do split phase, you can see that it does not quite line up. In other words, it is not exactly symmetric. And same thing if I do split halves as well, you get again a similar result. They do not line up nearly as much as what you saw in the previous example, which gives further credibility to the, in this case, the bimodal solution. So in summary, if split halves plot, they do not line up very well, if they are not symmetric, then it is more likely that the bimodal solution is correct. But if they do line up, as in this example, then the bimodal solution is a repetition, and you would want to seek out the monomodal solution. So I would encourage you, if you want to read more about it or have some additional understanding of it, then you can skim through this issue of the Minor Planet Bulletin and just look for different references to split halves plot or bimodal, and you can see how they deduce or determine which solution is more likely than the other. But for now, in this newer version of Tycho, you also have that capability. You can do the regular phase plot, you can do split phase, or you can do split halves. So this capability is now available. So if you're interested in trying it, you can do so. So anyway, that's about it for this video. Thank you for watching, and see you next time.